Welcome to Lab 5, where we are going to be exploring density differences and stratification in the ocean. You will be doing exercises 1, 2, and 3 from your lab manual, and the instructions will be included in this video. To begin with, I just want to give you an overview of what we're talking about here. As you see, there's a picture of the world with a greatly exaggerated ocean, and you can see the white arrows in it. Those are representing deep ocean currents. Well, some of them are. The ones on the top are obviously representing surface currents, and you see that they've given them different colors. The ocean water is not just one mass. It is actually separate water masses that tend to differ in salinity, how much salt is in them, and in temperature. And ocean masses, once they have a different temperature and or salinity, tend to form discrete masses that do not readily mix with each other, and they form separate currents. Temperature and salinity are the main causes of density differences in the ocean water and the main causes of deep ocean currents. In general, cold water is more dense than warm water, and more saline, more salty water is more dense than less saline water. The instructions for exercise 1 are as follows. First, read pages 65 to 66 in your lab manual before you begin. Watch the video clip that is embedded in this that will follow. Answer questions 1 through 10 once you've watched the video on page 68 of your lab manual in a Word document that you will submit to me using SafeAssign. Please note that we will not be sticking to the timeline described in the lab manual, that is 2 minutes, 5 minutes, and 9 minutes. What I want is for you to observe the progression of the mixing and stratification of the layers over time, roughly at the beginning, near the middle, and at the end. Also, you do not have to submit drawings of the colored layers, although you might want to sketch them to help yourself in answering the questions. We will be using the following code. Blue will be cold saline water, red will be warm saline water, green will be cold fresh water, and yellow will be warm fresh water. So I'm going to start with the temperature and water stratification demonstration. On the right, the green water is cold and fresh. You even see ice cubes floating in it. The yellow water on the left is warm and fresh. They are separated by partitions, but you can see that the water is already seeping out and starting to mix a little bit. There's 3 partitions. You may notice that in the middle to the left, the green water is mixing slightly with the yellow water. When I remove the partitions, the green water, which is cold and therefore more dense than the yellow warm water, is going to slide underneath because it's heavier, it's denser. And the warm water, which is less dense, which is lighter, goes over top of the heavier cold water. Now we'll just watch this for a few minutes. Take some notes, observations on what you see. Again, we're not going to be doing this in the intervals set out by your lab book, 2, 5, and 9 minutes, but I want you to watch the progression over time. Now, originally I took out the middle partition, but now I am going to remove the partitions at the end to let them more fully mix. You can see, hopefully, that there's a slight yellowing of the top layer, which again is warm and less dense than the cold green layer. And it's making its way across. This is an analog of what actually happens in the ocean when cold and warm waters come together. They are separate water masses and they do not readily mix. So now I'm going to take out some of my floating ice, and you'll see that you've got two currents going. The green is moving from right to left, and the yellow is moving from left to right. Having completed the questions on page 68 in your lab book on exercise 1, we will now move on to exercise 2, where we will study how salinity affects water stratification in the ocean. You will need to read the short narrative on page 69 of your lab manual before we begin. You will watch the video that I have embedded in here that demonstrates salinity and water stratification, and then you will answer questions 1 through 8 that are on pages 70 and 71 of your lab manual in a Word document that you will submit using SafeAssign. You can put exercises 1, 2, and 3 together. Note, we will not be sticking to the timeline described in the lab in the manual. That is 2 minutes, 5 minutes, 10 minutes, etc. What I want you to observe is the progression of the mixing and stratification of the layers over time, roughly at the beginning, near the middle, and at the end. And you do not have to submit the drawings that are requested in the lab manual of the colored layers, but you might want to sketch them because it will help you answer the questions. Here we are going to do stratification by salinity. On the right, the blue water is cold and salty, approximately the same salinity as the ocean, 3.5%. On the left, we have warm and salty water. It's the same salinity as the water on the right. It's approximately 3.5%. As you can see, because the partition has been removed from the middle, they are beginning to interact. The warm salty water is making its way over the cold salty water because it is less dense. When I remove the partitions at either end to let them mix more fully, the difference in salinity is shown even more dramatically. You can see that the warm salty water on the left has formed a current that is moving to the right. And it's because of the density difference that the current is being set up. And the blue cold salty water, which is more dense and therefore heavier, is making its way from the right to the left. So we have two currents set up here. Now the next thing I'm going to do here is I'm going to set up a surface wind. First, I'm going to do it by blowing a little bit to see how surface winds affect stratification in the ocean. Blowing didn't seem to affect it very much at all, so we're going to try a hairdryer and simulate a surface wind. Now the first thing it's doing is it's pushing some of that warm water back to the other side, and that's causing the cold water that's underneath it to well up. It's called an upwelling when water goes from the bottom to the top. It's welling up to replace the warm water which has been moved away. Once I remove the wind, some of that red warm water moves its way back over the top again. And the system reestablishes itself as warm on top and cold on bottom. Last but not least, exercise 3, we are going to create a multiple layer system here with fresh water that is both warm and cold, with saline water that is both warm and cold. I want you to read pages 71 and 72 in your lab manual before you begin. Watch the embedded video. Answer questions 1 through 5 that are found on page 73 of your lab manual. Put them in a Word document along with exercises 1 and 2 that you submit to me using SafeAssign. Again, we will not be sticking to the timeline described in the lab. I just want you to observe the progression of the layers over time, the beginning, the middle, and the end. Again, you do not have to submit the drawings of the colored layers, although sketching them will probably help you to answer the questions. I have now set up a system with 4 different densities. We have the blue, cold salty, the red, warm salty, the warm fresh, and the cold fresh. We are going to remove the layers between, let's see here, the warm and cold fresh to start. Again, we expect the green, which is the cold fresh, to be denser than the yellow, which is the warm fresh, and so it will tunnel its way underneath, creating a little mini current. Now we have the warm and the cold salty. I pull up the partition between those, and again we expect the cold salty to be denser than the warm and to tunnel its way under, again setting up a little mini current. Notice that the salinity, the cold saline water, which is blue, has a much stronger current than the cold fresh water, which is the green. In fact, it's already made it to the middle partition, and the green hasn't done that yet. Salinity makes a big difference. Now we're going to wait a little bit and see if we can get the green to advance over to the middle partition before we pull it. Again, the green is fresh and the yellow is fresh. The only difference between those two is the color. With the blue and the red, they both have the same salinity, and again the difference between them is the blue is cold and the red is warm. The fresh water obviously makes a much weaker current than the saline water. So we're still waiting for it to catch up, get to that middle partition. What would you expect to happen when I pull that middle partition? Get an idea in your mind, which currents do you think are going to be more dense and go underneath the currents that are less dense? What do you think the final stratification is going to look like? What do you think is the densest water? Which do you think is the least dense? Now the green is almost to the center, so I'll pull up that middle partition just a little, and as you can see, the cold saline water is clearly the densest. It is tunneling underneath the green cold water, the fresh cold water. The colors are starting to get a little blurred here, but I think you can still probably make them out. So I pull that partition all the way. You can see a wave of the warm salty water that went from the right to the left. Now I'm not sure how well you can see the color differences, but if you look closely you should be able to tell that the blue cold saline water is on the bottom, the red warm saline water is the second layer, the third layer is that green layer, which is the cold, and the top, it should be the yellow. In this video it doesn't look that much like the yellow layer is on the top. It looks like the green layer is on the top, but actually the yellow, the fresh warm water, is on the top, and the green cold fresh water is just underneath it. So from bottom to top we have cold saline, then warm saline, then cold fresh, then warm fresh. The top layer is the least dense, and so it floats on the underlying layers, each which is more dense than the layer that it is underneath. So let's add a surface current to this and see what happens. It's pushing the top fresh layers away, the green and the yellow, and you may be able to see that on the bottom it's upwelling in this direction. The blue and the red are being pulled back over here as the fresh waters are being pushed to this end, and it's causing a slight upwelling. But not a very strong one. In general, in the ocean, surface winds do not affect the deep layers very strongly. Deep ocean currents are essentially kept away and are secluded from the ocean winds that are blowing the currents on the top. They're two separate systems. So the top two layers are getting mixed. I don't know how well you can see that, especially with my head in the way. But the two bottom layers are pretty much left intact. Surface winds pretty much affect only surface layers of the ocean.